In this video, we are going to focus on our perpendicular lines. We've been looking at parallel lines and transversals, so we're actually just going to take that a step further and we're going to look at perpendicular lines, and we'll bring our transversal back in when we look at our proofs. So we're going to look at a couple of definitions first and how we use them, and then we're going to look at three theorems and we're going to use those theorems to do proofs. Alright, so let's start off with what we need to fill in here. What intersects at 90-degree angles? Can you fill it in? Perpendicular lines. Perpendicular lines intersect at 90-degree angles. And we usually know when we have a 90-degree angle because they tell us by our symbol and our symbol for our right angle. So we could say that these two lines are perpendicular lines. Alright, let's move on to our next definition. If a line, a segment, it divides the segment into two segments of equal length. That sounds familiar, doesn't it? Do you know what we're going to put here? Did you guess bisects? If a line bisects a segment, it divides the segment into two segments of equal length. Well, you already know that, don't you? Well, we're actually going to take these two concepts and combine them for our next fill-in. And we're going to say a perpendicular bisector of a segment is a line that is perpendicular to the segment at its midpoint. So if we are at the midpoint of a line segment, then we know that we have broken it into two equal segments. If we come over here and take a look at our diagram, we have our symbol for a right angle, so we know that this line is perpendicular to this line, AB perpendicular to CD. E, they're telling us, is the midpoint, so if E is the midpoint, then we know that the length from C to E is the same as the length from E to D. And they put the tick marks in, and we'll just highlight them as well. Alright, so let's use this concept and answer some questions here. Alright, if line PQ is the perpendicular bisector of segment RT and our S equals 4, let's find the following values. Alright, so if these are perpendicular to each other, I'm automatically going to put in my right angle symbol. And if this is a true bisector, that means this is our midpoint, then that also means that these two segments are congruent. So if I know the length from R to Q is 4, then I know the length from S to T is also 4. Alright, now let's see if we have enough information to answer our questions. Number 1, the length of ST. Come over here, and yes, we know what it is. It is 4. The length of RT, so the length of R all the way to the length of T. We use our segment addition postulate, 4 plus 4. And so we would get 8. And now we want the measure of angle PST. I'm going to just put the little angle symbol in there. The measure of angle PST, do we know what that is? PST, we sure do. We know these are perpendicular. We already put our symbol in, and we know that that's 90 degrees. Alright, now here's the theorems that we're going to take a look at. We have 3 of them. I'm just going to kind of talk through them and then we'll use them here in a minute. If two intersecting lines form a linear pair of congruent angles, then the lines are perpendicular. Alright, so let's think about that. Let's come over here to our picture. If angles 1 and 2 are congruent to each other and they are also a linear pair, they're forming this line here, line B, we know that linear pairs total 180. And if these are congruent to each other, then they both have to total what? Did you guess it? They both have to total 90 degrees. So we know that our two lines are perpendicular to each other. Our next one is called the perpendicular transversal theorem. And it states that in a plane, if a transversal, so we brought that back, is perpendicular to one of two parallel lines, then it is perpendicular to the other line. So let's come over here and take a look. H is our transversal. They're telling us that it is perpendicular to C. We have our symbol here. They're also telling us that C and D are parallel because we've got our parallel markings here. So from this, you can automatically conclude then that if H is perpendicular to line C, then H will also be perpendicular to line D. Okay? And our last theorem states if two coplanar lines are perpendicular to the same line, then the two lines are parallel to each other. So if we come over here, if two coplanar lines are perpendicular, so we're saying that line J is perpendicular to line L and line K is perpendicular to line L. So if both these lines are perpendicular to our transversal, then we will be able to conclude that they are actually parallel to each other. And we could put in our symbol. All right, so let's try a proof. Okay, we've been given some information, so we're going to bring that down here and we're going to make that our first statement. And we know why, because it is given. I'm going to come up here and I'm going to make my markings. R is parallel to S, and angle 1 is congruent to angle 2. What we want to prove is that line R and line T are perpendicular to each other. So let's see if we can do that. Well, we know something about parallel lines and transversals, don't we? Can we see a relationship between angles 2 and 3? I think we can. They are congruent. Do you remember why? Did you remember that they're corresponding angles? Right, using our corresponding angles postulate. So we mark those. Then, if we take a look up here at angles 1 and 3, now we can say that they are congruent to each other. And we passed on that value of 2, so remember that that's your transitive property and of congruency since we're working with angles. So actually, we just have one last step. Do you see what's happening up here? Do you see that angles 1 and 3 are congruent to each other? They're a linear pair, which therefore means they have to each total 90 degrees. So therefore, we can say that line R is congruent, or is perpendicular to line T. And that is the theorem one of the theorems that we just looked at. Remember that if two intersecting lines form a linear pair of congruent angles, in this case 1 and 3, then the lines are perpendicular. So that's a bit of how we use those. The last thing we're going to look at is our little diagram here, and I want you to pause the video. I want you to look at the three situations here, and I want you to use each of those theorems to make a conclusion. So pause the video. When you have your answers, turn it back on and check. All right, let's see how you did. Okay, if they tell us that angles 1 and angles 2 are congruent to each other, well, we can see that they are a linear pair. Therefore, we can conclude that line M and line P will be perpendicular to each other, right? Because we get that 90-degree angle. Remember that from our theorem. How'd you do on the second one? If angles 2 and 3 are both 90 degrees, do you remember what that means? That means then that we can conclude that they are parallel to each other. And remember our drawing on this one. Remember that states if two coplanar lines are perpendicular to the same line, then those two lines themselves are actually parallel to each other. And your last one, they tell us that the measure of angle 2 is 90 and that M and N are parallel to each other. So how'd you do on this one? That gives us a conclusion then that N and P are perpendicular to each other. And if we look at that drawing that we had up here, remember that in a plane, if a transversal is perpendicular to one of the two parallel lines, then it is also perpendicular to the other. All right, that concludes our video. Feel free to go back and rewatch it. This is a lot of information, and we will talk about this in class the next time we meet. And I'm also going to introduce another definition that we will work with when we do these.